Okay, everyone, we'll start the session since it is already 3 p.m. So, before starting the session, I want to know if I'm audible. Am I audible?
Yes, yes,
Yeah, and is my screen visible?
yes.
Okay, okay. Thank you so much. So, hello everyone, and welcome everyone to week 5 of the course Research Methodology for Natural Sciences. And yeah, today is week 5, and it's actually a very rescheduled session compared to every other Saturday. Like the previous 4 weeks, we conducted it every Saturday from 3 to 5, and this week, due to some unavoidable circumstances, we are shifting this session to today instead of yesterday. So, yes, so this week's routine will be similar to all the other 4 weeks. Vijay is how was open day at ISC? Yes, it was fun. It was actually a lot of work for us as well. But yeah, I think there was a lot of crowd at IASC, and I think the crowd was significantly less than compared to last year, since it was last year it was held after a lot of years due to COVID, and this year was just a continuation to that. So I think the crowd was much less, but still it was like tough to handle, I would say. So yes, so this week's routine will be much more similar to the past 4 weeks. So what we'll be doing is we'll be going over a brief recap of whatever was taught in the lectures of week 5 of the course, and then following that we'll be having a short doubt session, and then we'll be discussing last week's assignment answers. So in the previous 4 weeks, I have been receiving some suggestions saying that, and I have also been receiving suggestions from the course instructor that I am sort of discussing all the assignment answers before the deadline, which is sort of not advisable to do. So what we'll be doing, I'll be changing the routine of this session from this week onwards. So what I'll be doing is, I'll just be discussing last week's assignment questions, and then we'll be discussing if any of you have any complications or doubts with that, and then we'll be discussing few problems from the week 5's assignments. Instead of discussing all the problems like factual or descriptive problems, we'll just be discussing two or three problems which will normally involve a bit more of thinking, so that it will give you an idea of how to approach the answer. And then I guess we will be discussing the normal factual questions the next week's TA session. Yes. So and yes, as usual, like I would advise everyone in the call to mute their mics while joining. We'll be muting their mics, but uh, when not during the doubt session, or when we are not in the discussion of the assignment answers, I would advise you to mute your mics as well as your cameras. And the main purpose of this is to avoid any interference for the other participants who might have connectivity issues. Yes. So we'll get started. And so last week, yeah, I'll just go to my PowerPoint. Yeah. So last week was sort of week 3 and week 4, in fact, was sort of giving us a historical perspective into how materialism came into picture, and what were the struggles between materialistic and idealistic philosophies between scientists, how different people took different stands in different time periods with respect to materialism, and even in materialism, what were the branches of materialism, and how that worked with some people, and how that did not work with some people. For example, even in materialism, there was a subset of uh, empiricism called positivism, which also was under materialistic aspects, but many people did not or were not comfortable with that in later stages of modern science, partly because it didn't involve the study of particles or entities which were not visible to our eye. So positivistic approaches told us that we can study things, or we can observe things, or we can make conclusions out of things which were only visible to our eye. And this didn't help a lot of scientists who want to study the fundamental nature of all the physical, chemical, and biological entities in our universe, or even in our world or the solar system, and so on and so forth. It developed Isaac Newton, many scientists like Albert Einstein, moved forward the objective materialistic aspects, and then they were able to overcome this sort of pseudo materialistic fields or disciplines like positivism. And in the later parts of last lecture, we got a introduction into the main part of this course by getting an introduction into what scientists actually do, how do they frame questions, what are the things they need to consider while framing a questions, and what are the different kinds of steps they need to take into consideration while answering a question. So we got an introduction into what scientists generally do. So this week is sort of a continuation to the question and answering part of the last week's lectures, where we get into the various aspects of forming an answer to a question. So last week we learned how to frame a question. This week we'll be learning into what factors goes into while answering those questions. And the first part of the lecture starts with falsifiability and reproducibility. So these part of the lectures assume that we have already formed a set of answers or set of possible answers for a question. So the need for the lecturer Dr. Soumitra Banerjee starts the lectures with the need for falsifiability and reproducibility. And the main aim of those two aspects is to eliminate subjectivity in any scientific discourse, because scientific modern science or the quest for modern truth in science always involve an objective approach, and subjective approaches are generally not encouraged. So to negate or to eliminate the subjective aspects in this course, in this scientific discourse, we often go for aspects to solidify our answer to those questions, and the solidification process involves falsifiability and reproducibility of our answers. So the initial parts of the lectures starts with what form of conclusions do we arrive with certain premises. So whatever premise we have that leads to a logical, we have a premise and then we have a conclusion, and there is a logical discourse from the premise to the conclusion, and based upon the validity of the logic of the or the correctness of the logic, we are able to arrive at whether a correct premise can lead to a correct or incorrect conclusion. So the lecturer starts with the facts that when we take a correct premise and when we apply with a valid logic, we come with a correct conclusion. But on the other hand, when we take a correct premise and when we apply an invalid logic, we sort of end up with an incorrect conclusion, which is not part of a good, healthy scientific discourse. But on the other hand, even an incorrect premise can sometimes lead to an incorrect correct conclusion, provided we okay, there should be valid logic. So I'll just I think it's just a minor error that I made during PPT. So yeah, So yeah, so we also come to know that we can arrive at a correct conclusion even when we have an incorrect premise if we apply the valid logical discourse to the premise. And yeah, he also starts to explain the difference between a hypothesis and a postulate, because most of the scientific answers in the quest for finding scientific answers to scientific questions, we often end up framing hypotheses or postulates to find the answer. So before framing those kind of hypotheses or postulates or theorems, we need to define them properly what they actually mean. So part of these are like textbook definitions or Google like definitions to keywords. So hypothesis is basically a proposed answer to a question or truth. So when we ask a question like how did life originate on earth, maybe we have a question and we want to find an answer to that. So how do we normally try to answer the question is that we saw in the last week as well. So while trying to answer a question, we form multiple hypotheses, and then all of these should be testable hypotheses. They can't be taking an idealistic approach like because it is the power of will or fate or any suprahuman or subhuman entities that form life or something like that. We should take a materialistic approach while answering a question, and the multiple hypotheses are framed while answering a question, and each of these hypotheses are tested using certain experimental parameters, and through that we try kind of circle on the final hypothesis which appears to be more true than all the other hypotheses through proper testing, and then we go to framing an answer through that hypothesis. So a hypothesis is a proposed answer to a question or truth, and there can be multiple answers to a truth which can be true or false. The correct answer should be found by proper testing. On the other hand, the postulate, it suggests that postulate is an assumption considered to be true for further argument. So let's just say that we want to find the total angle in a circle. So for now, everyone, like in the present day, it's common knowledge that the total angle in a circle is 360 degrees. But in the olden days, what would a postulate be to assume to find the circle, uh, to find the total angle of a circle would be that they could take a circle in the first place, and then they would have to define a proper circle. A proper circle would be something which would be a collection of points, which would be the set of all points having a same distance from a certain point. So if we can take a circle, I'll just take a pen here. So if we have a point here, I have marked a point. So let's just take another point which is of a distance, and let us take another point which is of the same distance from, let's just mark it as O and A and B. So OA and OB will be of the same distance. So a collection of points involving the same distance from a common point O. And if you join all these points together, sorry for my bad drawing. So a collection of all these points having a same distance from a common point would be form a circle. So this kind of postulate would be established by scientists to proceed with finding the answer of what would be the total angle present inside the circle. So this is the definitions of hypothesis and postulates. So there were so we came across premises and how incorrect or correct premises can lead to correct conclusion or incorrect conclusions based on the type of logical discourse that we undertake. So a popular philosopher called Karl Popper came up with a theory of falsifiability, and he gave down certain points to say that this is the correct way to do this is the correct way to hypothesize and answer a question. And in his theory of falsifiability, he gave some points, and one of the points is that it's possible to falsify a theory because um, imagine a case where we have multiple hypotheses, like hypothesis 1, 2, 3, and until hypothesis 1 for a certain question. So how do we know that how do we know that whether only one of the hypotheses are correct or all the hypotheses are correct? So in order to do that, we must first come to a belief or conclusion that it's always possible to falsify a theory. Even if hypothesis 1 is correct at one point, and we arrive at a logical conclusion through a logical answer through hypothesis 1, at any other at any other time period, let's say 10 years from now or 50 years now, when some other scientist comes up with a better experimental setup to disprove the validity of hypothesis 1, so answer 1 also automatically becomes wrong. So the hypothesis that we are framing towards a question must always be falsifiable, and that's what Karl Popper says, that it's possible to falsify a theory, and a falsifiability criteria must be established while proposing a hypothesis. A hypothesis cannot be not falsifiable, and that will come only during a idealistic approach when we say that origin of life is because an act of God, which is an idealistic take on the origin of life. We can't falsify the theory because you can't do an experimental setup to falsify the theory because it's an idealistic perspective. And that's what the second point also says here, that progressively move towards by eliminating false hypotheses by properly testing them. And if we can't test them, such as idealistic entities where we can't test them, if we can't test them and prove them that they are wrong, we can't prove the hypothesis is wrong, and we can't prove the answer is wrong as well. So whatever hypothesis that we are framing towards a question, that must be falsifiable, and When we frame multiple hypotheses towards a question, we must find appropriate testing criteria to test all those hypotheses, and based on whatever hypothesis pass the test, we must negate the ones which do not pass the test and circle on and focus on the hypothesis which will pass the test, and focus on framing our answers based on the hypothesis which passed the test. And this was what Karl Popper mentioned in his theory of falsifiability. And yes, and the main domain of falsifying a hypothesis or falsifying a theorem mainly falls under theoretical work, where scientists theorize or hypothesize over some questions and then they try to answer a question. Whereas in another field of research called experimental work, another another facet or another property to eliminate subjectivity is known as reproducibility. Reproducibility is nothing but, suppose I do an experiment and I get an output. So um, let's just say that I have found an answer to a question by doing some experiments. I have got some data and then I have framed an answer for that. So another scientist who is like very far away from me wants to find the answer to the same kind of um, same question. So what I do is I give my data to him and ask him to find an answer for that question using my data. So if he uses my data and if he finds the same answer that I have found, then that is called as reproducibility. And reproducibility might should be taken always with a pinch of salt, because first of all, reproducibility is comes from the dominance of objectivity, and reproducibility is demanded because objective science should be taken forward. So when you mean objectivity, you should also take it with a pinch of salt, because there will always be a margin of error between certain things. For example, if you want to measure the pH of, I'll just say it in geographical terms. If you want to measure the pH of a certain type of soil, let's say clay is a black soil. So if you want to measure the pH of black soil in one part of India, and then you find it to be some value, we'll just call it X. So we'll ask some other scientist in some other part of his world, some other part of India, or in the world, to find black soil nearby his area, and then measure the pH of that soil. If he finds out that the pH is almost similar, like or not even almost similar, exactly similar, even if he finds the pH to be the same X value, then it is perfectly reproducible. But if the pH is, let's just say, zero point 0.1 or zero point 0.2 above or below the pH that we found in India, can we call it as reproducible? Can we call the same result as reproducible? Okay. So yeah. So in the end, that should also be like that result would also be called reproducible, but it should be taken with a pinch of salt, because any answer cannot be absolutely pinpointing to a certain value. While we measure the pH of any value, we should be performing the same experiment multiple times, and we should be taking a certain range of values to be true. And reproducibility is happens when some other person perform the same experiment and is able to obtain values in the same range as we get the answers as well. So that would be called as a proper reproducibility. And in the subsequent lectures, we also see about how we tend to measure quantities and how should we take values per se. And in the next parts of the lecture, the course instructor also highlighted how to propose a hypothesis. So the key steps to propose a hypothesis is to look for clues, multiple clues. Like he also at one point he compares look for clues like a detective, and then to propose the hypothesis based on certain requirements and desirable criteria. And by respect to requirements, he says that proposing a hypothesis should have the any form of hypothesis should form like certain mandatory requirements which should any hypothesis pass. So one of the requirements is an hypothesis should be consistent with the clues. And what does he mean by being consistent with the clues is the clues should be a logical consequence of the hypothesis. So, just as I saw in the last slide, previous slide, if we have a correct premise and a correct, we have a premise and a conclusion, whatever logical discourse that we are taking through connecting from the premise to the conclusion should be valid, and that is the form of a logical consequence. So if we have a hypothesis as a premise and a clue as a conclusion, there should be a proper logical discourse from the hypothesis to the clues. And second point is hypothesis should be based on material process and phenomena. Material process because we should be performing objective materialistic science, and anything which is idealistic we can't quantify or measure or observe. So those kind of idealistic entities we can't take into account. So since we want to take only those facets which are observable, measurable, and quantifiable, we should be taking only, like, our hypothesis should only involve material processes and phenomena. And same, the third criteria or third requirement also says that it has to have some testable predictions. So if any idealistic entity is there, we can't test to prove or disprove them. But if there is a materialistic entity, we can devise some form of test to predict what can happen to that certain entity. And it should be falsifiable. Just like Karl Popper said, any hypothesis should be falsifiable, and while proposing the hypothesis, a falsifiable criteria must be proposed. And apart from the requirements which are mandatory, he also said there are some desirable criteria for proposing a hypothesis. And one such criteria is fruitfulness. What will the hypothesis, how helpful the hypothesis will be in framing an answer. And scope. Scope is nothing but, like, scope is a normal scope that we have in science. How far can the hypothesis be stretched to obtain an answer? And simplicity. Simplicity is nothing but like, simplicity as in it should not be like a very, simplicity doesn't mean that it should be like made of very, hypothesis must be made of very simple words. I mean, of course, that is should be made of simple words, but that is just for comprehensive purposes for people all across the world. Everyone should be able to understand your hypothesis. That's why it should be in simple words. But simplicity here means that any hypothesis should consist of less number of a priori assumptions. So it should not contain more assumptions or more statements which we assume to be true before writing a hypothesis. And the last one is conservatism. Conservatism is desired for framing a hypothesis. And what do they mean by conservatism is any hypothesis that we frame, it should be consistent to the existing body of knowledge. So whatever we know, or whatever we know so far, um, our existing hypothesis is will be desired if it is contained within the body of knowledge. And sometimes you can also see that this is like form of a positivistic approach, but it does not necessarily say that it should be within the body of knowledge. If some part of your hypothesis is outside the body of knowledge, and if you have a proper testable ramification about it, then it is that hypothesis which is outside the body of knowledge will also be accepted. And in the end part of this module, the course instructor also gives us the different types of hypothesis. One is the null hypothesis and one is the alternate hypothesis. Null hypothesis just says that something is not the cause, not the cause or not the effect of something. So that will be the null hypothesis, and the alternate hypothesis will be the exact opposite of the null hypothesis. Something is happening or something is the cause of something, and he just gives some he just denotes null and alternate hypothesis by H naught and H1. And he also tells us that generally we try to take a proper scientific discourse by try to disprove the null hypothesis. If we cannot disprove the null hypothesis, then null hypothesis is commonly accepted. And um, if we can disprove the null hypothesis, then the alternate hypothesis is accepted. So one major hypothesis can be say by taking the example from the previous slide. Let's just say that null hypothesis can be something like the total angle covered by a circle will be 360 degrees. Yes. So then alternate hypothesis will be like sorry, total angle subtended by a circle can be will not be greater than 180 degree. Or so the alternate hypothesis will be the total angle subtended by a circle will be greater than 180 degree. So we try to come up with experiments to try and disprove the null hypothesis. And if we can find some experiments which tell us that the total angles obtained by the circle is greater than 180 degree, then we can disprove the null hypothesis and go with the alternate hypothesis. And in the last uh, modules of this week's lectures, we talk about the elements of scientific measurement. How do we measure the quantity? And most importantly, once we collect data points from an experiment, what do we do with it? So this is kind of like the whatever contents are discussed in this last two modules, and these are kinds of statistical modules. And mainly we start with mean. Mean is basically we call the average of several data points. Let's just say we have like 5 data points and all of them have a certain value. So the mean will be the sum of all the data points divided by the number of observations. And apart from the mean, we also need to know how each observation varies with the uh, average. How far or how close it is to the mean of the given type of observations. Therefore, from that we have two other parameters called variance and standard deviation. So for this, up till this point, you people need not memorize the form. If you are not from a mathematics background or a statistics background, you need not memorize this formulas per se. But we'll see if you guys need to memorize these formulas in future. And yes, so another concept we come across this elements of scientific measurement is population and sample. So population is the sum total of all the entities present in a given property. So let's just say that if you want to measure the beak length of all the crows in the world, so the number of crows will be literally millions and millions of crows. So we can't go and measure those. Those will represent the population. So a population will be the set of all the beaks of all the crows present in the world. So we can't go to each crow and then we can measure the beak length of each one of the crows. So what we do is we selectively enclose a particular amount of crows. That will be called the sample. So let's just say that there are millions of crows in the world. We'll just take hundreds or thousands of crows, for example. Those hundreds or thousands of the crows will form the sample of the population of crows. And we will just be measuring the beak length of those hundred crores or thousand crores, and whatever parameters we get out of it, mean length of the crow or standard deviation of the crow, we can say that we can say with a certain amount of confidence that whatever average length we get from the sample will be closer to the population. Yes. So there are the course instructor also gave some parameters or symbols to indicate population mean and population standard deviation, and sample mean and sample standard deviation. So this is not both the parameter, all the four parameters should not be like confused with each other. Population is something which indicates the sum total of all the given entities in some possessing some property, whereas sample is a subset of the population containing the same entity. And yeah, we finally go on to discuss about the normal distribution, which says that any form of property, if we measure any kind of property, will be when we try to record the data and try to plot it graphically, we will be sort of getting a bell-shaped curve. And there are some other instances as well where we do not get the bell-shaped curve, but there are most instances involve the graphically when you graphically represent most recording of most instances, we get this bell-shaped curve, and that is often called the normal distribution, where the mean, the central tendency, tends to have the highest number of observations, and the extreme or very rare tendencies tend to have many very less number of observations. And yes, so when we try to plot the mean and when we try to plot the standard deviation curves, this is what we get around with respect to the percentage of population or the area of curve subtending the standard deviation and the mean. So 95% of whenever we plot a normal distribution or a standard bell curve, we can confidently say that 95% of the population lie within 1.64 standard deviation of within the standard deviation of mean, and 99.7% of the population lie within 3 standard deviations of mean. And finally, in the last part of the lecture, the course instructor talks about random errors and systematic errors. So, random errors are whatever errors that cannot be avoided or eliminated. So, those are entirely up to natural causes, and random errors do not occur like due to any experimental errors. Whereas systematic errors happen because due to any systematic deviation of a sample from a population. So and they all like we also come to discuss about the various ways by which systematic errors can cause and can be removed. So one of the ways systematic errors can be removed is by using proper calibration. So by properly calibrating any instrument that with which we are trying to measure the quantity, we can properly remove the calibration error, which is one form of systematic error. And one more way by which we can remove the systematic error is to measure the same quantity in two or more ways. And yes, so this can be represented by discussing the voltage discussion in the lecture series, where we try to find the resistance of some thin wire. So while making different types of measurements using different methods, we can come with different values, and by summing them or averaging them, we can get an idea of how how the resistance of something can vary. And one more important thing by which we can reduce systematic errors is by grouping the data. So grouping the data either geographically or by any other means. So let's just go back to the black soil pH measurement by example. So the pH of black soil in different parts of the country or the different parts of the world might differ just because of their natural tendencies, natural geographical tendencies to stay with those properties. Maybe due to the maybe due to the temperature of the area or the salinity of the water surrounding the soil, the pH of the water can measure. So the incorrect way to proceed with finding the pH of black soil would be to club both the pHs from two different areas. Instead, what we can do is we can categorize them as black soil from place A and black soil from place B, and then record separate pHs from both the places. So yes, this is one more way which we can reduce systematic errors by grouping data more efficiently. So that was all the recap for week 5's lectures. So we'll go to a short doubts discussion till 3:40, and then we'll go on to discuss last week's assignment questions. If you people have any doubts with whatever recap we had, you can either type it in the chat box or you can raise your hand and you can talk through the mic. We have time is now 3:33, so we'll have time till 3:40, after which we'll move on to the assignment answer discussion for last week.
I have a confusion that what is the difference between postulate and hypothesis?
Oh, yeah. So what's the difference between postulate and hypothesis? Right, once again. Yeah. So postulates and hypotheses are two different things, and there are a lot of differences between both of them. So hypothesis is something which is sort of like a which we propose to find the answer to a question. So that itself can be an answer as well. So to take forward from a question, we form an initial part of an answer, and then we proceed to it. Maybe we can like hypothesis can be like you just say that something can maybe this will be the cause of it, or maybe that will be the cause of it. For example, like if you have a question like how did life originate, um, you can form a hypothesis saying that life formed because of chemicals. But that won't be true. You would have to test whether life actually formed due to chemicals, and then find out, and then either approve or disprove the fact whether life either formed due to chemicals. And on the other hand, postulates are assumptions that you hold to be true. So once you form a postulate, you don't need to, sort of um, do any experiments to prove or disprove the postulate, because once you disprove the postulate, the entire answer will be gone along with the postulate. So you just assume the postulate to be true to find answers to whatever question you have. So one example that I told for postulate is the example of a circle. So if you want to find the total angle subtended by a circle, formed by a circle, now in present day everyone knows that it's 360-degree. A circle forms 360-degree. But in olden days, how people who used to have found the answer to the question is, first they would have thought of something, how they could define a circle in the first place. So they would have defined circle as something, collection of points from a common point having the same distance. So this they would have formed as a postulate, and they would never ever do experiments to approve or disprove the statement. Only when the circle Only when the circle is defined, the angles attended by the circle will be 360 degrees. So that will be the difference between hypothesis and a postulate.
Thank you.
Yeah. Any other questions or doubts? We'll wait for 2 or 3 more minutes before we can start the Q&A session. Okay. Earth revolves around the sun is a hypothesis or a postulate. So, initially, what they would have done. So, Earth revolves around the sun is, in present days, it's actually a theorem. Like, there have been experimental evidences surrounding, the, there have been experimental evidences which tell us that, and observations from space stations as well as something which tell us that earth revolves around the sun, and not the other way around, sun revolves around the earth. But initially, in olden days, or in the early days of modern science, they would have formed a hypothesis that earth revolves around the sun, and whatever experiments they would have done with respect to proving that statement would have formed the theorem that earth revolves around the sun. Okay, thanks. Ravindran is saying some data saying it is null hypothesis, which means it is non-significant, and this non-significant means there is no change in data related to control data. I have to. Can you rephrase the question properly? Like, I can't understand part of your question. Okay. Now I can understand. So I am thinking that you mean to ask. So null hypothesis is something which is okay. Yeah, actually you are correct, Ravindran. Like whatever question you are trying to ask is correct. So null hypothesis is something which you will approve, not like disprove, you will approve when whatever um whatever experiment you do, whatever test you perform, has no significant difference between your experiment and the available data. That's when you conclude that you can approve the null hypothesis. If there is any significant difference between whatever test you do, there are many statistical tests, right? T tests, F test, and ANOVA and all those stuff. If you find any statistical difference between um, experimental data and your sample data, then you will reject the null hypothesis and accept the alternate hypothesis. Is it clear or okay? Okay. So yes, we'll move on to the question session. So uh, compared to last week, yeah. So this is what I was saying in the beginning of the lecture as well. So compared to last week, there will be like compared to not even last week, compared to all the previous 4 weeks, this week and the subsequent weeks will have sort of a change in how we approach this session, because I have been getting some feedback from the course instructor saying that the answer discussion before the assignment deadline is not kind of encourageable. So what we will do instead is we will discuss the last week's assignment, and then after that we will have a short doubt session for that last week's doubt assignment questions, following which we'll be having like a short discussion session on um, some problems in assignment 5, some problems in assignment 5 which require thinking or something. I won't be going over factual questions which we can just factual questions as in a question has a certain answer, you don't need to think anything, you can just tick mark and go on. So those kind of questions we won't be discussing. We'll be discussing only answers which might require some thinking or which are kind of twisted. So these are questions from assignment 4 in week number 4. So the characteristic features of a metaphysical outlook are they are given 4 options and it's a multiple select questions. So does anyone want to answer this question? I'll open the chat box as well for yes. So metaphysics, as we called it in the like metaphysics was discussed in the last week, and metaphysics told us that everything is fixed or nothing can change, and there is no like change of one object from one to another. Trees can be trees and shrubs can be shrubs. There can be no other object between trees and shrubs and so on and so forth. So everything is fixed. There is no in between entity between two distinct objects, and every object will have its own distinct properties. Okay. So if no one has an answer for it, I'll just give the answer here. So yes, so metaphysics says that um, everything has fixed, and so the answers are the belief that everything has fixed properties, option A, and the tendency of viewing things in isolation from their condition of existence, option C. Madhuri says A. It's A is correct, but it's a multiple select question as well. So you might want to think more and see what other option also goes with it. Yes. So the other options, the understanding that everything is in the process of change and evolution, that is not metaphysics. That is completely materialistic. And then the idea that the Earth is at the center of the universe doesn't fall into any other category as well. So if no one has any doubts with it, we'll go on to the next question. Like I'll give one minute for this, 1 or 2 minutes. Okay then. So we'll go on to the next question. So yes, the characteristic features of mechanical materialism are. This is also a multiple select question. So mechanical materialism is something which in which people believed that everything in the universe is form of a form follows a immutable laws. Yes, B. Saurabh Kumar and Gupta, B and C. Correct. Yeah. So its optional answers are viewing the world as law governed, requiring no divine intervention, perfectly materialistic approach, and law everything is law governed. Everything follows an immutable law. And then also they thought of the world as a gigantic mission. So just as how a mission has certain parts, and understanding that um, if you everything goes wrong with the machine, you should do something with the part. You should repair the part. Just like that, if they thought the world of the genetic machine and all the entities in it as individual parts. So question number three, positivism asserted that. So positivism is, as we discussed in last week, it's a subset of empiricism. Shaurabh Kumar is saying D, the source of knowledge is sensation we receive through our five organs. Um, but there should be an MSQ once again. So I mentioned it here that there is an MCQ or an MSQ. So I guess you guys should like you people should also give another answer. Roshni, Karthikeyan, and Gupta, B and D. Yes, it's correct. So positivism asserted that whatever we observe, whatever we record, it should only be whatever we record and whatever we study, it should be only something which we can observe and measure, and whatever um knowledge we have, it should only be the perception of our five sense organs. So whatever we can't see through our naked eyes, whatever small or big, we can't study them because we can't see them. In a way, it sort of um, it was a killer against idealism, because it also said that idealistic approaches are not the way to go forward because we can't see any of them. But on the other side, it also hurt materialistic aspects because none of the subatomic, atomic or subatomic particles or molecules can be studied in further detail because of this. Only macroscopic objects could be studied in science. So if anyone has no one has any doubts with this, I'll go on to the next question. Gupta, yeah, you can go ahead. Arjun, I have one. Yeah, you can go ahead. What question do you have?
Myself, Subhash Gupta.
Yes, yes.
Uh, Sir, the one more view about this question is the source of all knowledge is the sensation we receive through our five sense organ.
Yes.
So, can we include one more that is our thinking? Means if we are not taking any signal from these five senses, okay?
Okay.
So, from the thinking also we generate some knowledge. So, what about that part?
So, thinking. So if you ask about thinking, maybe so thinking can be split into like two parts. One can be the functioning of the brain. One is something called as consciousness. So we will say that human beings are in the highest chain of consciousness in the world. Consciousness means the ability to think and make decisions on your own. So you can in a positivistic approach, you can't study consciousness because you can't see them. Consciousness is sort of a feeling, so you could not study consciousness. But on the other hand, you could study brain function, how maybe brain works, or how brain is composed of, maybe
Actually, I am sorry to interrupt you.
yeah, sure.
I am talking about the cognitive science. In fact, in our cognition process, we can also generate some knowledge.
Yes, but I don't know. Like this is kind of, I mean, now cognition is also considered as a knowledge or source of science in the modern scientific. So after positivism, we came on to scientific materialism, and in that domain, knowledge or cognitive science is also considered a very important and very progressive field in science. But I am still not sure how that would be considered in positivism, maybe.
right, sir. This was my just perception. So it's okay, sir. Thank you, sir. Thank you.
Yeah, sure. Good question actually. Because one more thing, like one more reason why positivism existed and they didn't allow scientific materialism to progress forward might be because they didn't think of these kind of um, sorry areas of areas or disciplines like cognitive science. Maybe there could be a reason.
Yes, sir. Yes.
Even while studying historical perspective, we could only discuss about what kind of historical data we already have in our hands. So that's why I think we might have to dig deep into what an older scientists or scientists in the past thought about um, cognition. That would maybe give us more answers into what kind of approach they had, whether they had a positivistic approach or a scientific materialistic approach towards answers.
Yes, sir. Yes.
Yes. So Jansi
Okay.
is
Thank you.
saying, yes, yeah, sure. So Jansi Rani is saying it would be great if you help us with upcoming assignment answers too. I don't know about others' opinion. So Jansi Rani, so one thing is that we are discussing week 4 answers right now. After that, I will discuss some problems from week 5 assignment as well. Yes. So I'll be discussing only like some of the uh, trickiest problems maybe in week 5. The other answers, which are a bit more factual, I'll leave it to you people. I won't be discussing it in this session, but if you guys want any help, you can maybe shoot it up in the Google groups as well. The discussion forum which the NPTEL has for every course, you can shoot that question up in that Google groups discussion as well, or you can maybe shoot that question after the towards the end of the session when we'll be having a doubt session. We can see how uh, good it is, and then we can come towards an answer. Okay, then we'll move on to the next question. The characteristic features of scientific materialism are. So yeah, scientific materialism, everyone knows it came after positivism, and it came after the um, experiments of Maxwell and all those people. So Roshni Raj saying B and C. Yes, correct. So scientific materialism basically said that everything is in a change, as opposed to the metaphysical aspect. Metaphysics said that everything is fixed, but scientific materialism said that everything is in a flux, everything is in a state of change. So what actually matters is that we need to study the change instead of the object itself. So when, for example, when something, let's just say when a cell grows into an organism, we should study the change when the cell goes from a cell to an organism rather than the cell itself. What is there in a cell? Yeah. So the correct answers are the understanding that everything is in the process of change and evolution, and the realization that processes are more fundamental than things. So yeah, processes as in changes from one state to another. Those processes are more important, and everything is in the process of change and evolution. Does anyone have any doubts in this part or in this question? If not, I'll move on to the next question. So next question is Einstein believed in. It's a multiple choice question. So this is a very simple question. Scientific materialism. There is no other like. It's a very pretty factual question. And so coming back to Jansi Rani's question in the chat box. So these kind of factual questions in the week 5 assignment, I won't be I won't be trying to discuss them today. Maybe you can shoot these kind of questions. If you have doubts in these kind of questions, maybe you can shoot them up later in the discussion forum. Yes. So next question. Boltzmann's work was rejected by scientists of that time because it's a multiple choice question, and same, it's a very factual question. So it was because he based his work on the assumption that atoms and molecules exist. And if no one has any doubts, yeah, as Gupta is right, C is the correct answer. He based his work on the assumption that atoms and molecules exist. So I'll move on to the next question. A closed question is, so this is also a multiple choice question. Only one answer is correct, and pretty much a very factual question. So we have two types of questions. Roshni Raj is correct B. So we have two types of questions: a closed question and an open question. And a closed question is something which will, if you have a question and if you answer the question, it won't lead to further questions. For example, if we want to find the value of a constant, the gravitational constant or Planck's constant, we will find the value, and that answer of that value does not lead to further questions. You can't ask a question like, why is it like that? It's like that because we have experimentally proven it to be like that. So you can't ask any further questions from that. On the other hand, an open question is something where you can ask further questions from a existing answer itself. So next question. Thomas Kuhn proposed that. Thomas Kuhn, we all know that he is a famous philosopher, and he discussed about the normal science and revolutionary science. So this is a multiple select question. Gupta is once again right. A and D. So there are evolutionary and revolutionary developments in science, and the development of science is marked by paradigm shifts. So development of science almost comes uh, like when during the normal science is something where people make smaller increments in science. They find questions to regular stuff, and when the questions in smaller science, the normal science comes to a saturating point. What the revolutionary scientists do is they try to think out of the box to make a paradigm leap or paradigm shift to find problems to complex problems, and then once the problem is solution is found, they revert back to finding normal solutions, problem solutions to normal problems. So if anyone has any doubts with this, I'll leave the room for 1 hour, else we'll go to the next question. Yeah, Gupta, you can go ahead.
Sir, about the evolutionary it means natural evolutions or the man-made evolution.
No, 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 no. It's evolutionary development as in it talks about a development. So evolution does not, in this context, the evolution does not naturally mean natural evolution. Evolution just means the development of some field or some development of something.
Okay, sir. Okay, thank you, sir.
Yes, I mean, in general English, we can say that um, a child even evolved to a man. So that is also a form of evolution. Yeah. Piyush, you can go ahead.
What is the difference between evolutionary and revolutionary developments?
Yeah. So evolution. So yeah, I think people are confusing between evolution and revolution. Like last week, also I had some questions regarding this. So Thomas Kuhn said that there are two branches of science. One is the normal science, and one is the revolutionary science. The normal science is another name is only evolutionary science. So evolutionary science is something which makes very small increments, very like smaller increments in science to find solutions to day-to-day problems. Maybe, for example, let's just say, mm, maybe we can say that how is the why is a pencil bent when it is kept in water? So that is a kind of a normal question which will give us a smaller increment to our knowledge. So we can, if you try to find the answer to why is a pencil bent while it's kept in water, you can find the answers to reflection of water, reflection of uh, light and water, about refractive index of different kinds of medium, how refractive index changes for different kinds of medium, and then you can find out the answer between what is the uh, what is the kind of answer to why is a pencil bent in water. On the other hand, revolutionary science is something which takes a very larger increment in science. So when normal science have some questions and these questions keep on saturating. So when scientists feel that they can't keep answering questions, they need something else on the other side to keep answering these smaller questions. That's when we have a larger leap. Like some scientists try to find answers on a very large scale. The science can also be engineering developments. For example, when James Watt invented the steam engine, so that steam engine was a revolutionary development because many people used that kind of engines to make furthermore engines, and industrial development, industrial revolution came. And using the engine, people made very significant progress in society. Like people started making many missions using the steam engine as a concept. So the steam engine itself was a revolutionary development.
Okay.
So if no one has any other doubts, we'll go on to the next question. One second. Next question. Gupta, yeah, you can go ahead.
Sorry, sir.
Yes,
I
yes.
am. Can we take the programming language development as evolutionary or revolutionary?
Yes, uh, mm, programming language, I'm not pretty sure. But if you ask me whether the invention of computer is a revolutionary development, then I would say that it's a revolutionary development because the invention of computer led us to many modern applications, uh, of which programming languages are also one.
Just like television, so it came very first
Exactly,
in black
exactly.
and white, then it
Ex-
colored, then smart, and then.
Exactly, yes. So yeah.
So,
So 20
okay.
years ago, 20 years ago, we used to have that cathode ray tube based monitors.
Yes, yes, yes.
Yeah, and then it has slowly developed to LCD and LED, and now we have sheet based TVs. So those are kind of small evolutionary developments. But if you what actually what actually is the main common thing that is behind them is transistors. So the development of transistor would be a revolutionary development.
Yes, 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 yes. Mm.
Yes.
Okay, sir. Thank you, sir. Thank you.
Yeah, sure. So we'll go on to the next question. One second. Yeah, next question. So which theory in science resulted in the development of mechanical materialism? So this is also a very factual question. Yes, Roshni Raj is correct. Option C, Newtonian mechanics. It resulted in development of mechanical materialism. And yes, last question. So regarding the existence of molecules, the position of positivism was. This is also an MCQ question. Only one option is correct. So this is also pretty factual. So positivists say that if anything is not observable, they do not exist. We do not need to study about them. So option is option D. Since they are not observable, they do not exist. So we are done with week four's assignment question discussions. So I'll leave the room for another. Time is 4:03 now. I'll leave the room till 4:10 for any other questions regarding assignment 4 or week 4 uh, areas. We can discuss them, and at 4:10 we can move on to week 5, discussing some of the key problems in week 5's assignment.
So you gave an example for evolutionary thing like computer invention, right? Can you
Yes.
give me an example for revolutionary one?
Sorry.
Can you give me an example for revolutionary thing?
Revolution can be something like transistors. That's a revolutionary development.
Okay.
Because only because of transistors you were able to come up with. So semiconductor technology developed so much because of the development of transistors. We are having so much electronic devices which all of them have some involvement of transistors in them.
Okay. Thank you, sir.
Yeah.
What is difference between metaphysics and supernatural things?
Metaphysics and sorry.
supernatural things.
Metaphysics and supernatural things are entirely two different things. So supernatural things are something which are not natural. Yeah, Gupta, I'll come back to that statement yet. So coming back to Piyush, so supernatural things are something which are not natural per se. For example, ghosts or whatever we can say, some things like that. So whatever idealistic stuff which we can't prove or disprove in our in any scientific materialistic aspect, that is called as supernatural stuff. Whereas metaphysics is something, it's a discipline of science. Metaphysics itself is a discipline of scientific science, but it's not exactly scientific materialism. It was a form of materialism that said that whatever materialistic components we have, that metaphysics entirely deals with materialistic components only. It says that whatever materialistic components we have, that is fixed, that cannot change at all. So let's say we have a small plant as an example. So metaphysics says that a small plant uh, will be a plant. It will not be anything else. It will not be any shrub or it will not be any herb. It's just a simple plant. And once it becomes a tree, it is a tree. So it will not be, once again, it can't become any shrub or a herb. And two more things what metaphysics says is, what like in the first thing is, metaphysics says that everything will have distinct properties which it will not share with anything else. For example, a tree will have a certain properties of its own which it will not share with anything else. A shrub or a herb will have their own distinct properties which they will not share with anything else. That is the second thing. Third thing is that there is no in between. So if there is a tree and there's a shrub, there cannot be anything which can both be a tree and a shrub, which can share the properties of both tree and shrub. You can only have either a tree or a shrub. So these are what metaphysics or metaphysicists said. But later it came to everyone's um, thought process that metaphysics cannot be like taken forward because there are always exceptions to metaphysical aspects. And one such aspect which we discussed in the last week was the existence of a platypus. So animals normally they were classified into either mammals, as in milk producing animals, or egg laying animals, animals which laid eggs. So metaphysicists said that there weren't any animals which are egg laying mammals, which produced eggs and which are mammals as well. But platypus came out to be an exception, which platypus is actually an egg laying mammal. So it came to be somewhere in between both of them. So these kind of exceptions denied metaphysics as a dominance. So metaphysics, but in the end point, metaphysics is something which dealt with materialistic aspects, whereas supernatural entities are something which is not materialistic.
Okay, thank you.
Gupta is saying something which revolutionizes the world is revolutionary. Yes. So one important thing to one important thing you can consider is that you can't like particularly like you can't have two baskets. It's like CN and computer vision. Yes, exactly. So, one endpoint that I can say, one takeaway message that I can say is you can't have two aspects like two baskets like evolution science and revolution science and then assign every development in science one to only one of those baskets. So, compared to one thing, another thing will also always be revolutionary. So, compared to computers, transistors will always be a revolutionary aspect, and compared to maybe transistors, electronics or how diodes and all those semiconductors came into existence, that can also be revolutionary compared to transistors. So uh, in a way all of these things are just relative to each other. How revolutionary they were will always be relative to each other. Yes. Yeah, I'll keep the room for one or two more minutes, then we will go to questions in week 5. Okay, then, if there are no doubts, I'll go on to week 5's uh, question discussion. Right now, I have just developed. Right now, I think I'm going to discuss only 3 questions because all the others were sort of factual. So after that, if we have any doubts in week 5's recap or week 5's questions, you can shoot up till the end of the session, which is like 5 o'clock. So let's move on. So, one has proposed the hypothesis A and has found an experimentally testable prediction B. So, I hope the question is clear. So, they have proposed the hypothesis A and they have found a prediction B. Saurabh Kumar is saying D. If B is found to be false, then hypothesis A can still be true. Um, Gupta is saying modest tolerance. Vijay is saying C. If B is found to be true, the hypothesis A is false. Roshni Raj is saying D. Can so before going to the discussion of options, so I'd like to clarify this thing with Gupta. So Gupta, you are saying modest tolerance, right? Um, in a way, yes, but try to sort of find correlate with the first slide of our lecture where we discussed about valid and invalid logics instead of modest tolerance and modest tolerance, because that comes entirely related to logic. It can be applied here as well, but try to think that. Okay, Mary is saying A and B, but it's a MCQ, so we can only give one option. Yeah. Okay, so lot of us are going with other like many options, so we'll just um, get what's the answer. So it's B is found to be false, then the hypothesis A is false as well. So there can only be the, like, yes, like Gupta, you're correct, but it won't come under modest tolerance because modest tolerance is part of deductive logic. So yes. So Saurabh Kumar is saying D. So let's go over the other options as well. So Saurabh Kumar is saying D, where if B is found to be false, the hypothesis A can still be true. So okay. So Saurabh Kumar, this kind of this B is found to be false. The hypothesis A can still be true, can not be valid because, so if let's just say you apply hypothesis A and you apply valid logic and still you find B to be false. So one outcome of that is that even B can be false because of other conditions as well, not just because of this hypothesis A. That could just mean that the testing condition is not that good enough to uh, out outcompete A or outthrow A. Same goes for option C and option A as well. So if B is found to be true, the hypothesis A is false, and B is found to be true, hypothesis A is true as well. So um yeah, so A cannot be option A. The B is found to be true, then the hypothesis A is true. That cannot be true because even an incorrect form of premise can give, through a valid logic, can give rise to a correct conclusion. So if B is true, then does not necessarily mean that hypothesis A is also true. And if B is found to be true, And it does not also necessarily mean that hypothesis A is false as well, because through again through valid logic, a false premise can give rise to a true conclusion. So only option could be, if B is found to be false, then the hypothesis A is false. So we'll move on to the next question if no one has any doubts.
Sir, excuse me. So this has to be based on the logic, is it? If it's an invalid logic, then we cannot.
Yes.
Okay.
So
Yes.
the correct option is basically like incorrect conclusion, invalid logic. So obviously like incorrect, sorry, incorrect premise, invalid logic. So obviously incorrect conclusion.
Okay.
Gupta, you can go ahead. I didn't read your comment actually. Sir, I am looking it as A, B, and B, then A. Yeah, that's what. So, rather than taking into a model, like your answer way of getting to the answer is correct, but just I'm saying that instead of taking it through modus tolerance, which is like a very deductive logic approach, you can just take it through the form of premises and conclusions and application of valid logic.
Okay, sir. Thank you. Thank you.
Yeah, yeah, sure. So, one more question. So, suppose a person has died and a scientist forms a hypothesis about the cause of her death. It should be based on. So, here we are, Vijay is saying B and C, the facts and the circumstances of her death obtained through the observation, material processes and phenomena that can cause death of a person. Roshni Raj also saying B and C, Saurabh Kumar B and C, yes. So, okay, before coming to the answer, we'll just go over all the options and see which one of them is correct or wrong, or maybe correct or maybe wrong. So, first option, her horoscope, the assumption that fate had a role to play, completely idealistic approaches, which goes against the requirement of framing a hypothesis, saying that um, hypothesis should also always be uh, based on materialistic phenomena. Same goes for option 4 as well. The possibility that she committed a sin in her previous birth. So that is also a very idealistic thing, because we can't correlate the any relationship between sin and death. So the correct options would be the facts on the circumstances of her death obtained through observation, and material processes and phenomena that can cause death of a person. Mary, you're also correct. B and C. So does anyone have any doubt with this? So this question entirely is based on how to frame a hypothesis. The mandatory requirement that hypothesis will should always be based on a material phenomena, not any idealistic phenomena. So we'll go to the last question of today. So the necessary features of a scientific hypothesis are, this is like entirely factual, but I'll just leave it to you people to see how what answers do you come up with. Roshni Raj is saying B and C and D. Vijay is saying C and D. Yeah, so okay. Gupta is saying A and D. Okay, so okay, multiple people, multiple answers. So like all three are correct. Yeah, Karthikeyan is actually correct. So it's A, C, and D. So because we'll go over the options one by one before coming to the conclusion. So first option is, it should satisfy the observational facts about the phenomenon. So this is just another way of saying that it should be like it satisfies like what to say, uh, two kinds of things. So first is the hypothesis should be consistent with the clues. So like clue should be a logical consequence of the hypothesis. So this point satisfies the fact that clues will be a logical consequence of the hypothesis. Sorry. Okay, I think it's just a disturbance. So yeah, so coming back to the discussion of the answer, so it should satisfy the observational facts about the phenomenon. Just means that we have some observations and as a logical consequence of the observations we come up with the hypothesis, like we should frame the hypothesis. So A is a correct option, and one must have arrived at the hypothesis through deep thought and is an idealistic process. So it can't be counted into while framing a hypothesis. It should be falsifiable, plain and straight, like Karl Popper's falsifiability theorem. It should have been experimentally or observationally testable predictions. Absolutely true. It should be testable, and based on the test, if it's not coming out to be true, then the hypothesis should be rejected. So A, C, and D are all correct options only. So Saurabh Kumar and Karthikeyan, like I think yeah, you guys got it correct. Yeah. So these are all the questions which I thought like which would be tricky enough, or I think people would be forgetting one or more points. The rest all questions were like pretty factual, and I don't want to discuss that because I'm getting some feedback from other people to uh, that we are discussing all the answers. So apart from that, if you have any like kind of doubts with respect to week 5 content or week 5 answers, the session is almost open for the next 40 minutes. Yes, so like if we can have a doubt session for 40 minutes, and if we don't have any uh, doubts after like 10-20 minutes, we can close the session. Vijay is asking reproducibility and replicability difference. Um, mm, on a surface level, I don't find any difference between them. Like both of them almost mean the same only. Can you like does that satisfy the answer, or like
So, what is conservatism?
okay? Uh, Vijay, I'll come back to this question. Meanwhile, Vijay, can you try to rephrase your question, because okay, I'll answer Kumaraswamy's question and come back to you. So Kumaraswamy, so conservatism is basically nothing but your you have a hypothesis. Whatever hypothesis you are trying to frame for a question, it should exist within any existing body of knowledge. Uh, it should not involve something which no one has tested with, or no one has any answers for. That is what conservatism means. For example, let's just say that mm, yeah, yeah. Let's just say that maybe at you know mm, I'm trying to think of some hypothesis. Just give me some time.
Okay. Okay.
Yes.
అవును కొంచెం చూద్దాన్ని కూడా.
Okay, so okay, we can come up with this simple example. So I think we all of us use toothpaste as an example. Toothpaste in our everyday lives to brush our teeth, and many people say that like almost all of the toothpastes have some fluoride content in them. So one like many studies say, like many studies, not even many studies, many people propose or hypothesize that this excessive amount of fluoride is not like harmful, like it's like harmful for your teeth. It can erode away your enamel or do some bad things for your teeth. Therefore, like like fluoride should only be limited in your toothpaste, and not sort of um, it's not helpful for your teeth, it's harmful for your teeth. So um, for this we'll just consider that there have been no like great studies in studying effect of fluoride on teeth. So if we don't have any studies on the effect of fluoride on your teeth, whatever, first of all you must take every component of your teeth and enamel and gums and all the stuff. So you should try experimenting to see what happens if you add different concentrations of fluoride, any fluoride salt over the teeth or gums or enamel, and then see what happens. And you should have previous data that this actually causes degradation of these particular kinds of cells or this particular kind of tissues or something like that. If you don't have any data with respect to anything that fluoride causes something to dental health, then it's proposing or hypothesizing that fluoride causes teeth degradation is actually the outside the body of scientific knowledge, because
It
there
is,
haven't been enough studies in dental health which have been done to prove that fluoride actually causes some changes in teeth and all the stuff.
matlab, based on the available knowledge and laws of nature. I say, sir.
Exactly, exactly. In some cases, maybe in some cases whatever hypothesis you are framing can be slightly outside of body of knowledge, and if you can manage to prove that thing as well, then your hypothesis can be accepted.
Sir, what is the reproducibility of the scientific result implies?
Yeah, so reproducibility is nothing but so let's just say that I'm doing an experiment, I'm getting some values, and someone else wants to do the same experiment, same kind of experiment, and if he gets the same values as I did, then it means that the experiment is reproducible.
Okay.
If he gets different kinds of results, then it means that the whatever experiment I did, it's not reproducible. For any scientific experiment must be reproducible for it to be taken with confidence. If it's not, then you cannot confidently accept it as a valid scientific experiment.
matlab, we are getting the same result.
Yes, if you perform the same kind of experiment, you should be getting
Okay.
the same result.
Okay. So it is a good or not good, sir? Same. Matlab, that means that some study conducted in that some other scenario that we are doing that here in that another setting, then it will be good or not?
It is good only. So see what we are saying, in the same experimental setup, two different people are getting the
Okay.
same result. So it just increases confidence in that particular study or conclusion.
Okay. Okay.
Yes.
सर पोस्टुलेट मतलब क्या है सर?
So postulate is nothing but whatever we consider to be true before going on to find an answer to a question. So between an answer and question, we have something which we assume to be true, regardless of whether it is true or not. And then using the truth, we try to find an answer.
Okay.
Sir,
One second, Mukesh. I'll come back to you because
yeah, sorry.
I had already asked a question. So, reproducibility and replicability difference. Um, can you rephrase your question now, Vijay? Like, is it possible? Are you talking about like technical replicate and other types of replicate? Vijay, are you there? Okay, okay, cool then. Mukesh, you shoot your doubt now. Can tell your doubt now.
Yes, sir. Sir, what is the meaning of simplicity in hypothesis implies means simplicity what implies in hypothesis?
So in hypothesis, simplicity means that while framing any hypothesis, you can't have many assumptions about many assumptions about many things. It should be simple enough. So the more number of assumptions that you have in a hypothesis, the more number of experiments you need to do to validate that hypothesis. That should not be the case. Instead, an hypothesis just should just contain minimal amount of assumptions so that your experimental procedure or experimental stuff will be simpler or much more easier or lesser. If you have many assumptions about any hypothesis, and let's just say when you are testing your hypothesis, one of the assumptions tend to be wrong, whole hypothesis tends to be wrong, and there is no use for all all the remaining assumptions as well, whether regardless of whether they are correct or not.
Means sir, it was a simple language or a few pure assumption.
Yes, it should have few a priori assumptions.
Okay, sir. Thank you, sir. Got
Sure.
it.
Okay.
Sir, this class is a little bit different from the normal statistics class. I thought a little bit different these topics.
Sorry, sorry.
This normal null hypothesis, what we are studying, it is little bit different, sir. Here, that content.
The null hypothesis and the alternate hypothesis.
Yes, yes, sir.
I mean, so no, like in this course for now, we are just trying to simplify the definition for null hypothesis and alternate hypothesis.
Yeah, and that actually natural science, this method, this little bit different. What we studied, na, this all the terms, this falsibility, this all the things. First time we are hearing.
Okay, one second. Sorry, 1 second. Sorry for the yeah. So what are you saying, Kumaraswamy?
This course, we are studying this terms as a falsibility. This all the terms now something new from the statistics which we didn't studied earlier. So that thing.
Yeah, because of the courses basically highlighted to underline fundamental stuff that we need to know while learning natural sciences. Natural sciences as in the physics, chemistry, biology, and mathematics. So while
Okay.
learning this fundamental sciences, what are the essential, like most fundamental things that we need to know before proceeding? So every definition that we give to course, those who take the course are very boiled down, like they are very simple and fundamental. Like we try it not to be very advanced because many people from diverse backgrounds choose this course. I think Kumaraswamy is saying that this course is not covering too much statistics. So that's the thing. So main thing is that even you can even see it in the week one's course that what we are trying to outline in the overall course. So many of what we are trying to do will not cover too much statistics or hardcore mathematics. Rather, it will teach you how to properly form a hypothesis, how to properly answer a question, and what are like errors and what are the scientific ethics that we need to follow in while doing scientific research, so on and so forth. I think next week you'll be having a bit more mathematics, like not mathematics that you need to perform by hand.
Yeah, yeah. Yes,
Yeah.
sir. Yes, sir. We saw that. More questions.
Yes, yes.
Mean median. Yes. Sir, this falsibility means what, sir?
Falsifiability.
Ah,
So falsifiability just means that any like hypothesis should be falsifiable. Falsifiable as in It cannot be so. If you had observed week one's lectures, you would have seen that truth is not absolute. It is always relative. So depending on any experimental setup, truth can be changing from one day to another day. So if we find something to be true, it is true only till it's found not to be true. So the same thing goes for any hypothesis as well. It is true only till someone finds a better experimental setup to falsify it or to find that existing hypothesis as false. So that's what
Okay.
is falsifiability means.
Fabricate false like that, sir. It will be come.
No, no, you won't be fabricating false hypothesis. Like you will be experimentally proving that the hypothesis is false. That is what falsifiability means. Fabricating is actually not the proper scientific ethical way to do scientific experiments. You should be proving it experimentally that some hypothesis is false.
Acha.
Yes,
First one, possibility the theory can be proved false through the observation or experiments like that, sir.
yes, yes, yes.
Okay, sir.
So Vijay is saying, can you explain null hypothesis? Okay, so I think I gave like in the lectures we had a very boiled down definition, and like someone asked for a more technical definition, and then we gave it. So a more technical definition of null hypothesis is that there will be no significant difference between the sample data and the population data, or whatever data we use for a hypothesis and whatever data that is available for the population. If there is no significant difference between that, then we take on that as the null hypothesis. We go on to the alternate hypothesis, which will be the exact opposite of null hypothesis.
Opposite statement of alternate hypothesis, I guess, no, sir.
Yes, alternate hypothesis is the opposite of null hypothesis. So, in very general terms, null hypothesis will just say that something X is not the cause for something. And in alternate hypothesis, we just say that in like I'm just saying in like fill in the blanks kind of stuff. So in null hypothesis, we will be saying X is not the cause for Y. Whereas alternate hypothesis will say that X is the cause for Y. Did you get it, Vijay? Okay, meanwhile, okay, yeah, sure. Mukesh Meena, I can go ahead.
Yes, sir. Sir, the this subject is means useful for in research if we are doing the PhD in next few year or any planning for that. Then this is the useful for us, sir, as technical subject in technical subject.
So I think so it will be useful. So on overall the course will be very useful because it teaches you a lot of things about scientific ethics and scientific behavior. But whether it will be useful for your PhD, that depends on with like as in whether it will be useful for your PhD coursework, that has to be decided by your PhD PI. So, for example, some colleges will not accept NPTEL courses, while some other colleges might accept NPTEL courses as their degree certificate as well. Yes. So you can, if you have doubts like this, maybe you can ask the NPTEL team. There is some disturbance. Can someone, everyone mute their mic?
Yes, sir. Okay, sir. Thank you.
So bottom line is end of the story, end of the day messages. If you have any kinds of doubts with respect to course selection or NPTEL, you can contact your PhD advisor or you can contact your NPTEL, contact the NPTEL team through the discussion forum.
Yes, sir. Thank you, sir.
You also part of the team, sir.
I am not part of the NPTEL team. NPTEL team, like they are from NPTEL. They kind of resolve these kind of technical issues with respect to
Okay.
NPTEL coursework and all those stuff. I am
Okay.
just a teaching assistant from IASC who I am working with the course instructor to uh, take a recap and discuss assignment questions and stuff.
Uh, you are doing job or you are studying, sir, over there?
Okay, I think I forgot to give an introduction of myself in the start of this lecture. So, I am Arjun and I am a second year PhD student in IISc Bangalore. So, yes, so I am the assistant of this course, and I am not the only teaching assistant. There is another teaching assistant for the same course, Uditya Saha. He is taking TA sessions on Tuesdays from 7 to 9.
Acha.
Okay.
Thank you, sir.
Yeah, yeah, sure. Thank you, guys. Yeah, yeah. Thank you, Gupta.
Good morning.
I'll leave the room till 4:45 open. Like, if we don't have any questions till then, we will close the session by then. Yeah, sure, anytime, Ravindran. So, and one more clarification is that only this week the TA session is on Sunday from 3 to 5. Because I had some, because IASC had their open day yesterday from all day, 9 to 5. That's why I couldn't organize the teaching a session from 3 to 5 yesterday. So I had to reschedule the class from instead of yesterday to today. So I I hope this will be the only instance where this happens. If not, then like every other class will happen every other Saturday from 3 to 5. So the next class would be would be on 2nd March Saturday from 3 o'clock to 5 o'clock. Thanks. Okay then. So if we don't have any other doubts, I think we can end the session here. I'll once again I'll thank you all for coming, and I'll see you guys on 2nd March Saturday from 3 p.m. to 5 p.m. Thank you.
Thank you, sir.
Yeah, thank you.
Your session is very interesting and useful.
Yeah, thank you.
Thank you.